Hi, welcome back to College Algebra. In this week 6, we're going to talk about systems of equations, and we'll begin introducing polynomials. We'll cover 3.3, 4.1, 4.2 of our textbook. And again, please look over these measurable outcomes, list of skills that you need to know for the week. Okay, 3.3. We're going to talk about how to solve system of linear equation by using the addition method. In the previous method, we talked about how to solve system of equations and different cases that we might see in the solution set. In this lecture, we'll talk about the addition method, also known as the elimination method. So again, we're going to have a linear equation in standard form: ax plus by is c, and the goal is to kind of eliminate one of the equation by multiply by the appropriate constant, so that one of the coefficient is the opposite of the other coefficient in the other equation, and helping us to eliminate one of the variables. So I think the key here is to kind of look at an example. So suppose I want to solve this system of equation. So one way to do this is to multiply the bottom equation by 4, and the reason why we do that is because we want to eliminate the y variable. And notice that if I multiply by 4, I'll get -4 in the first equation and +4 in the second. So these coefficients are opposite, so when we add them, they will cancel. And so the next thing is when we add the equation, we add them, we get 3 plus 16 is 19x. These will cancel, and this is 38. X is 2. Now that we have x is 2, we can go back into any of the equation, plug in x is 2 to find the y value, which is 1 in this case. And so this is the addition method, is to multiply by the appropriate constant so that the two equations have opposite coefficients, and then add the equations. Okay, so that's basically the addition method. Feel free to look over this to kind of summarize that method, but let's see some more examples. Okay, here's another example. And first thing is we want to write these in standard form. Notice this is not in standard form, the second equation. So let's move things around. We'll keep the first one the same, and we'll move the -4y to the other side so that everything is in standard form. And then we're going to multiply. Notice now we want to eliminate one of the variables, and it's not obvious from this how to choose which variable to eliminate. But let's do the x variable. And so that means that we want these to be opposite coefficient. So 4 and 3. So one way to think about this is think about the least common multiple of 4 and 3. And so the least common multiple of 4 and 3 is 12. So you want to get 12 from these two equations. One is positive 12, the other one is negative 12. So to do this, we're going to multiply the first equation by 3 to get the positive 12x. Notice 3 is multiplied by every quantity. So 12x, then this is 15y, and then 2 times 3 is 6. The bottom equation, we want to get -12. So we multiply this by -4. So -4x, 3x times -4 is -12x. Multiply the rest by -4 to get this. Notice now we have opposite coefficient. We'll add them, eliminating the x variable. So 15y plus -16y is -y. So we add these two equations. This will cancel. And then 6 plus -4 is 2. Y is -2. We go back and plug in y is -2 into any of the equation to get the value of x, which is 3. Okay, same thing here, but one way to so everything is already in standard form, so we don't have to do that part. And then the next thing is we were gonna clear the fractions. So notice we have some fraction here. So when we work with these, we don't want to have any fractions, so we're going to multiply everything by 10. The reason why I picked 10 is because 5 and 2 here, 10 is the least common multiple of them, and so when we multiply by 10, we can eliminate the two denominator. So multiply the left by 10 and also the right by 10. So we do that, I get on this side 10 divided by 5 is 2x, 10 divided by 2 is 5, so you get -5y, and 10 times 1 is 10. And now we have that the top equation has no more fraction, So now we want to see how we can eliminate one of the variables. So again, I can do either x or y, but if I would eliminate x, then I want the least common multiple of 2 and 4 is 4. So I want this to be 4 and negative 4. So multiply the top by 2 to get 4x. The bottom will leave it by itself because it's already negative 4. So now we can combine these by adding, and we'll get that 0 is equal to 0. Notice this means that essentially when we have an identity like this, 0 is equal to 0, which is a true equation, that means that these two equations are equivalent, and we have the infinite solution case. And so one way to write the solution to this is to pick one of the equation, any of them, because they're the same. So I'll pick the second one, which is a little bit easier, and solve for y. If I solve for y, I get that y is equal to negative 20 plus 4x, all divided by 10. And so one way to write this is to write for because this is an infinite solution, for any value of x, as long as y satisfies this function of x, then we are on the equation of one of the lines. They're the same line, and therefore the solution set is essentially all the points on this line. So this is another way of writing the set of all points on this line. Okay, here's another one. Again, we want to put everything in standard form. So first equation, we move the negative 3x over. Second equation, we might have to do some algebra. So distribute the 20, for example, and then move everything on all the x and y on the left side to give us this. So now that we have that, we can now proceed. And in this case, again, we're going to pick the x variable. We want to keep them to be the same. So this is 3x, 120. So one easy way is to kind of divide by 120, actually, by negative 40 to get negative 3 here. So notice if I divide by negative 40, the reason why I do that is because if I divide by negative 40, everything gives us nice numbers. We don't have any fractions. These are multiple of 40. So instead of making it bigger, again, we could make this negative 120, and that would also work. But it's easier to make it smaller. So divide everything by negative 40, and now we have that these are opposite. We can add them. Notice when I add them, I get an equation that's not true. So this is an inconsistent equation. So what that means is that this set of two equations will not give us any solution. So the solution set is the empty set. And so this system is inconsistent. So these two equations are parallel lines, and they will never meet. So we have no solution. Okay, let's talk about exponents and scientific notation. So this is a quick review of exponent, laws of exponents. If I multiply two quantities that have two exponents have the same base, I add the exponent. If I divide, I subtract the exponent. If I raise a power to another power, I multiply the exponent. And then if I raise a quantity to an exponent, I distribute that exponent to both of the product. And then if I have a quotient, I raise it to a power. Then again, I can distribute the exponent to each of the quotient, the fraction of the quotient. And so we've seen this already in algebra. Hopefully you've seen that already. But let's just kind of see some example. Let's talk about some special cases of exponent. So any real number that is not 0 raised to the 0 power is 1. So for example, 5 to the 0 power is 1. When you have something that is to the negative exponent, we can put the exponent to be positive and flip everything. So that if this is a negative n, I can make it positive n by taking this and put it down to the denominator. And then if you have a negative exponent and you have a fraction, you can flip the fraction. So b a of b to the negative n is b over a to the n, and then we distribute the n to both the numerator and the denominator. Okay, so let's see some example. So negative 2 to the 4th power, again, that just means that negative 2 multiplied by negative 2 4 times, and so that will give you 16. This one's a little bit tricky. It has to do with order of operation. So negative 2 to the 4, this is not positive 16. And the reason because when we do order of operation from the mnemonic PEMDAS, we do so parentheses exponent. Exponent is done first before multiplication. So 2 to the 4th power is 16. Then we multiply by negative 1. So this is actually negative 16. And then same thing here, you take out the negative 1 because we have to do exponent first. And notice because 2 to the negative 4, we can make this positive by flipping it. So the 2 to the 4 is now the denominator. And then we get 1 over, this is negative 1 over 16. And then in part D, anything to the 0 power is 1. And then in part E, x to the 0 power is 1. And then negative 7 times 1 is negative 7. Because these all have the same base, we just add the exponent. 3 plus 5 minus 2 is 6. So this is x to the 6th power. When we divide, we subtract the exponent. 7 minus 4 is 3. And when we raise the power to another power, you multiply the exponent. 2 times the negative 5 is negative 10. So this is negative 10. We want everything. We usually want exponent to be positive. So again, to make this positive, we put everything at the bottom. We flip. If it's at the bottom, we put it on top. If it's at the top, we put it at the bottom. Okay, so we want to simplify this by putting everything into positive exponents. So again, all this is to the 3rd power, and then all this is raised to the 2nd power. So this power can distribute to each of these. So 2 to the 3rd power, and then a to the 7 to the 3rd is 3 times 7 is 21. So again, we multiply the exponents. 3 times the negative 4 is negative 12. 4 square is here, then 2 times 3 is 6. 2 times the negative 2 is negative 4. And now we can simplify the coefficients. For example, 2 to the 3rd power is 8. 4 to the 2nd power is 16. And then now we can use the like basis. So a to 21 divided by a to 6. Subtract the exponent. 21 minus 6 is we subtract that, and then negative 12 minus negative 4. So simplifying, we can simplify the coefficient. 8 and 16 becomes 1/2. And then 21 minus 6 is 15. Negative 12 minus negative 4, that becomes a positive 4, which makes this negative 8. And then again, to make everything positive, the b to negative 8 goes down to the bottom, becomes b to the 8. And then there's our final answer. So again, please make sure you look over this carefully. Let's talk about scientific notation. Sometimes we have numbers that are either very large or very small. We want to have a nice way to write that. So instead of having all these zeros for a small number or all these zeros for a big number, we're going to write these numbers in scientific notation. So this uses powers of 10 to do this. And so a number is in scientific notation if it can be written in the form a times 10 to the n, where absolute value of a is between 1 and 10. And this n is an integer. Okay, let's see some example. So again, this is a big number, so we want to write this in scientific notation. So we basically take the decimal point, move it so that the number that we get is from 1 to 10. Again, this is that number has to be from 1 including up to not including 10. So if I move all the way to here, it'll be 9.3. Because I moved this 7 places, I need to write times 10 to the 7. So again, 10 to the 7 means that I move to the right by 7 places. If I move this to the right 7 places, I get the same number again. Now if I go the other direction, so I need to take this decimal and move all the way over here, so that again, this number needs to be between 1 and 10. So 9.11, again 9.11 times, this is 31 places, so that means that I need the exponent to be negative 31, because that means that I take this exponent, this decimal, and I move to the left 31 places. So again, negative exponent means I go to the left. If I go to the left, I get the original number. Another way of writing this is to write, especially if you have something like a scientific calculator, it might use this e notation. So 9.11 e to negative 31 means that, again, this is the same thing as 10 to the negative 31. So you might see this on a calculator. And also on web work this week, when we do your web work assignment, it will use this notation. Okay, and so in each case, right, notice that we use power of 10 to kind of place the decimal at the right place, and so this power of 10 is sometimes called the order of magnitude, or the magnitude of the number. And so, for example, the distance between the Earth and the Sun, which is this number right here, the first number. Notice we can say the order of magnitude of it is 7, for example. and then the order of magnitude of the mass of an electron is negative 31. So again, this should be a typo here. This should be 7, and this is negative 31. Oh, this is 10 to the 7, and this is 10 to the negative 31. Okay, so let's kind of go back and forth between standard notation and scientific notation. So for example, if you have a number like this, we want to move it so that is 7.5. So it'll be 7.5 times 10 to the 7, because this is moving 7 places. And then let's see. And then for a small number, again, we're going to move the decimal all the way over here. So it's 1 times 10 to the negative 9, because we need to move left to get the original number. And this one, 1.25 times 10 to the 11, because we need to move this 11 places to get this big number. And negative 8, because we need to move this decimal to the left by 8 places to get this number. Okay, so here's another example. Suppose that the distance between the Earth and this galaxy is approximately 1.8 times 10 to the 6 light years, and assuming that 1 light year is 6 times 10 to the 12 miles. The question is, what is the distance in miles to this Andromeda galaxy? And so we will need to multiply these numbers. Again, this is the number of light years, and every light year is this number of miles. So we multiply them, we get the total number of miles. When we multiply, we can use our exponent rules that we learned earlier. And so 1.8 times 6, and then 10 to the 6 power times 10 to the 12, we add the exponents, so that would be 18. And so we have this number as the number of miles. And again, this is not in scientific notation, because this number is not strictly less than 10. So we need to move it over 1 place. If I move over 1 place, that means I have an extra 10. And so that 1 place will give us 19 places. Okay, let's talk about how to add and subtract polynomials. So what is a polynomial? Polynomial is an algebraic expression that is in powers of x, and all the term has a to the x to the n, where a is a real number and n is some integer exponent, some whole number exponent. So a is called the coefficient, n is called the degree of the term. So for example, 3x to the 5th, 3 is the coefficient, 5 is the degree, x to the 14. 14 is the degree, and there's a 1 in front of it, so the 1 is the coefficient. A constant has a degree 0. X to 0 is 1. And then 1/2 p, 1/2 is the coefficient, and the degree is 1. And so a polynomial that has exactly one term is called a monomial. A 2-term polynomial is binomial. A 3-term polynomial is called trinomial. And usually when you have terms that have polynomials that have multiple terms, we usually put in the degree in descending order, where the highest degree goes first, and the coefficient for that is called the leading term. The coefficient for that is called the leading coefficient, and that term is called the leading term. The degree of polynomial is the biggest degree of all the terms. So for example, here's a monomial. It has 1 term. So monomial has 1 term. Binomial has 2 terms. Notice that these are 2 different terms, and the terms are combined by adding or subtracting. So I usually put this in. We usually want to put it in descending order. So for example, in this case, I put the highest term first, and then that means the leading coefficient is -7, and the degree is the highest degree. So that degree is 2. And so in this case, again, we put the coefficient of the highest degree first. And then the degree of the whole polynomial is 1 here. So these are binomials, and trinomials has 3 terms. Notice. So again, if I rearrange it, the degree here is 6. The degree of the polynomial, the entire polynomial, is the highest degree, which is 6. The degree of this one is 8. The leading coefficient of this is 9. The leading coefficient of this is the coefficient of the highest degree term. And then sometimes you have polynomials that have multiple variables, and so in that case we have to add the exponent to get the degree. For example, the degree here is 4 plus 3 plus 1, which is 8. The degree here is 3 plus 2 plus 7, which is 12. The degree here is 2 plus 1, which is 3. The degree here is degree 0. and so this is the highest degree here. And so the degree of this entire polynomial is 12, which is the highest degree. We add polynomials is very simple, which basically add like terms. So for example, if I add these two polynomials, I just combine all the like terms. So 3t cubed plus t cubed is 4t cubed. 2t squared plus, there's no t squared term, so leave that alone. And then minus 5t minus 6t, that's negative 11t. So basically group like terms and then combine like terms by adding the coefficients. So same thing here, we combine the w squared terms. So 2/3 plus 4/3 is, we combine those numbers, and then the w terms, I can combine these, and then the constant term, I combine those. And so 2/3 plus 4/3 is 6/3, which is 2. And then the linear term, negative w plus 8w is 7w. And then we combine the constant term to get negative 1/8. Same thing with the polynomial has multiple variables. Another way to do this is to kind of organize them vertically, so that notice these are same powers, means that it's the same. We can combine them like terms. So 1 plus 5 is 6. Again, they have to be the same. 2, 2, 1, 1. And then these like terms can have the same powers for all the variables in that term. And so 7 minus 2 is 5, and then 6 minus 7 is negative 1. Subtracting is the same thing, except now we just subtracting instead of adding. So the one thing we have to be really careful is that when I subtract a polynomial, this subtracting is applied to all the terms. So this negative distribute to each of the term. So for example, minus 4x squared, minus a minus becomes a positive 7x, minus 2 becomes minus 2 here. And then we can combine like terms by adding. So 3x squared plus minus 4x squared is negative x squared, and 2x plus 7x, combine like terms, is 9x. Negative 5 minus 2 is negative 7. A polynomial function is a function is defined by a finite sum of terms of the form a to the xn. So for example, f of x is 3x minus 2. We saw this as a linear function. So that's a polynomial. This is notice again, this is a degree 5 polynomial, and so these are functions that are given by polynomial function, I guess. So these are called polynomial functions. These are not polynomial functions because notice, right? This is again. Notice that all of these powers must be whole numbers, positive integers, non-negative integers. And if you have absolute value or dividing by x, then these are not. Divide by x means that it's negative 1 exponent, and we need it to be non-negative integer powers. Okay, suppose I have this polynomial function. How do I evaluate using function notation? So p to negative 3 means I plug negative 3 into each of the x term. So again, we saw this in the last lecture when we talked about functions. So evaluating the function at negative 3. Note negative 3 substituted for all x's. So negative 3 to the third power is negative 27. Again, make sure you're careful with the order of operation. Negative 3 to the square is 9. And then minus x means minus a negative 3 becomes positive 3. Then we combine all these to get negative 8. Same thing here. You substitute negative 1 to where you see all the x's. And then we just simplify. And negative 1 to the third power is negative 1. So you have to be careful with the negative and positive. But once we simplify, you should get 0. Plug in 0 is very easy. Everything becomes 0 except for the constant term, which is negative 2. Yeah, so this is how we basically evaluate polynomial at specific constants. And same thing for the last case. So make sure you check over, make sure that you get these same answers. So let's end with the example of an application with polynomials. Suppose that I have a rectangle where the rectangle is the length of the rectangle is 4 meters less than 3 times the width. So for example, 3x minus 4 is the length, and then the width is x. So if x is the width, then the length is 4 less than 3 times the width. And suppose that we want to write a function that represents the perimeter, which is the sum of all of this. And so if x is the width, then here's the dimension, and the perimeter is twice the length plus twice the width. That's adding all these to get the perimeter. So notice if I do that, 2 times the length plus 2 times the width, and I simplify by distributing the 2, for example, 6x minus 8 by distributing, and then 2x, and then simplify everything. I get that this is a polynomial function that represents the perimeter of my rectangle. In particular, this polynomial function is a linear function. The degree is 1. Okay, thanks for watching.